Hello everyone, I am Dr. Anita Thomas. Today's lecture is on homogeneous differential equations of order 1 or first order homogeneous differential equations. So what is homogeneity? A function g of x comma y of two variables x and y is said to be homogeneous of degree alpha, where alpha is a real number, if g of tx comma ty is equal to t raised to alpha g of x comma y. That means if you put in this function, replace x by tx and y by ty, you will get this type of function, and the result should be like that. You can take out t raised to alpha, and there is our first function g of x comma y. Then we say that g of x comma y is a homogeneous function of degree alpha. Now, differential equation. A differential equation of the form m of x comma y dx plus n of x comma y dy equal to 0 is said to be homogeneous if m and n have the same degree of homogeneity. That means m of x comma y is of order 2, then n of x comma y is also of degree, means here also degree of degree 2. Then only we can say that this differential equation is of homogeneous of order same degree, same degree. Now solution method. Before going to solution method, I request you to recollect the integration by partial fractions from your +2 classes. So it will help you to do the problems very quickly. So step 1, we must give a substitution y equal to vx. V is a function of x, implies differentiating with respect to x, dy by dx is first function v into derivative of x, 1 plus x into dv by dx. Y, v is a function of x. Now we substitute these quantities in this equation number 1, and we arrive at a differential equation with the dependent variable v and the independent variable x. That means we are replacing y by v. Now we solve this the new equation by usually two methods: variable separable method and a first order linear differential equation method. For these two methods, please watch my previous videos and convert, then you will get a solution in v and x. Now our question is in x comma y, m of x comma y and n of x comma y. So we have to convert the solution obtained in step 3 to a differential equation with a dependent variable y and a independent variable x. Now verify that verify that each of the following equation is homogeneous and solve it. First one, x square minus 2y square into dx plus dxy dy equal to 0. Now I took this expression as g1 of x comma y and this as n as g2 of x comma y, and testing for homogeneity, g1 of x comma y replaced by g1 of tx comma ty, getting t square into 2y square minus x square, which is our g1 of xy. Thus the first quantity is homogeneous of degree 2. Now consider second quantity. It is g2 x comma y. It is xy. G2 here give the substitution tx and ty to x and y, getting t square into g2 of x comma y. Thus both these m and n are homogeneous functions of same degree 2. Now we can proceed to the solution. Solution is, I write like this, dy by dx, from this one dy by dx is 2y square minus x square by xy. So put step 1, put y equal to vx and dy by dx is v plus x dv by dx, and give the substitution to this equation. So v plus x dv by dx is equal to y is vx. So here v square x square minus x square by x into vx equal to 2v minus 1 by v after cancelling the common factors x square. So x dv by dx is equal to 2v square minus 1 by, here it is 2v square minus 1, 2v square minus 1. So 2v square minus 1 by v minus this v, this one minus v. Thus we get v square minus 1 by v implies, see here it is x dv by dx, and here it is v square minus 1 by v. So from these two quantities we know that it is variables separable. So arranging it in proper form, v by v square minus 1 dv is equal to dx by x, which is variables separable. So integrating out, we get, see this is the derivative of v square minus 1. So half of ln of, by substitution we get half of ln of v square minus 1 is equal to ln x plus ln of c, which can be written as ln of v square minus 1 equal to, multiplying by 2 ln of x plus 2 ln of c, that is ln of v square minus 1 is ln of x square c square, implies v square minus 1 equal to x square c square, getting y square minus x square equal to c square x raised to 4. Now next question. X square y dash minus 3xy minus 2y square equal to 0. What is y dash? It is dy by dx, and I wrote it in the standard, almost standard form, x square dy, then denominator dx will go to these two terms, getting minus of 3xy plus 2y square into dx equal to 0. Checking for homogeneity, see the power of n here is 2, only x square 2, and here both the terms, here 1, here 1. So 1 plus 1, 2. So this term has power 2 for degree 2, and this term y square, so it has also degree 2. That means both these two terms in m has degree 2 and this has degree 2. So this is a homogeneous equation of degree 2. This is another way to calculate the homogeneity, degree of homogeneity. Now solution, put y equal to vx and dy by dx is v plus x dv by dx. Substitute I substituted these quantities in this equation, getting x square v plus x dv by dx minus 3x into y is vx minus 2v square x square equal to 0. That is v plus x dv by dx is x 3v x square plus 2v square x square divided by x square, getting 3v plus 2v square. So x dv by dx is this v get cancelled with this one, 2v plus 2v square, that is 2v into 1 plus v. So see x dv by dx, and here is a function of v alone, so it is variable separable. So dv by 2v into v plus 1 is equal to dx by x. Now solution, integrate dv by 2v into v plus 1 equal to integral of dx by x plus ln of c. Then the constant, the shape of or the structure of these two terms, there is a chance of getting ln, so I took the constant as ln of c. So 1 by for solving this function, integrating out this function, we need partial fractions. So 1 divided by 2v into v plus 1, then a by write the denominators as linear factors, a by 2v plus b by v plus 1. We have to find out a and b. For that, multiply throughout by 2v into v plus 1, so that we get 1 equal to v into v plus 1 plus b into 2v. So put v equal to minus 1, getting b is equal to minus half, and v equal to 0, we get a equal to 1. Substitute these quantities here. So this equation becomes a is 1, so dv by 2v, and b is minus half, therefore minus half into dv by v plus 1 equal to integral dx by x plus ln of c, and half ln of v minus half ln of v plus 1 equal to ln of x plus ln of c, that is ln of v by multiply throughout by 2, so ln of v by v plus 1 is equal to ln of these two x 2 ln of x plus 2 ln of c, that is ln of x square c square, that is v by v plus 1 equal to x square c square, that is y by x plus 1 equal to x square c square. You can simplify this. Now third problem, dy by dx is equal to x plus y plus 4 divided by x minus y minus 6. This is another type of equation which can be reduced to homogeneous differential equation of order 1. So for that we need a substitution. X is equal to x plus h, capital X plus h, and y is equal to capital Y plus k, where h and k are constants. If we can find out such h and k satisfying some conditions, we can convert this equation to homogeneous. So what is dy by dx? dy is capital D capital Y, and dx is d capital X, and h and k are constants. So dy by dx is d of y by x, dy by dx for the capitals. So dy by dx is equal to, in the place of x put x plus h, in the place of y put y plus k. Here also getting x plus y plus h plus k plus 4 divided by x minus y plus h minus k minus 6. This can be made homogeneous if we can find out h and k such that this constant values, these two constant values are equal to 0. That means sum of these quantity is equal to 0 and sum of this quantity equal to 0. Then we can say that this expression can be reduced to homogeneous form. So solving for h and k, we get k is equal to -5 and h is equal to 1. This is a linear equation. You can solve it for getting the value of h and k. So that small x is capital X plus 1 and small y is capital Y minus 5. Now equation number 1, that is our question, reduces to dy by dx is equal to x plus capital X plus y by capital X minus y. See, it is evidently power 1, 1. So numerator is of degree 1 and denominator is also of degree 1. So this is a differential equation homogeneous of order 1. Now solution. Put y equal to capital Y. Capital Y is equal to capital Vx, which implies dy by dx is equal to v plus x dv by dx. Then giving these values to this step, we get v plus x dv by dx is equal to x plus vx by x minus vx, that is 1 plus v by 1 minus v, and x dv by dx is v plus 1 plus v by 1 minus v minus v. Taking LCM, 1 minus v into 1 plus v, we get 1 plus v square by 1 minus v. Now 1 minus v by 1 plus v, thus we get 1 minus v by 1 plus v square dv is equal to dx by x. So step 3 implies integral of solution. Solution is integral of 1 minus v by 1 plus v square dv is equal to integral of dx by x plus ln of c, which implies 1 divided by 1 plus v square dv minus v divided by 1 plus v square dv equal to dx by dx integral plus ln of c. See, the integral of this quantity is tan inverse v plus this is derivative of this one, lac of 2. So half of ln of v square plus 1 equal to ln x plus ln of c. That is tan inverse v is equal to ln of cx into root of v square plus 1. Now we have to give the substitution for v and v. That is tan inverse v is y by x. From here v is y by x equal to ln of cx into root of y square by x square plus 1, getting the answer tan inverse, and you substitute, then you substitute for y, what is small y plus 5, and x, from here what is x, capital X is x minus 1. Similarly here also substitute the values of x, y, we get the answer as tan inverse y plus 5 by x minus 1 equal to ln of c into root of y plus 5 the whole square plus x minus 1 the whole square. Now homework. Then another important problem. If a not equal to 0, not equal to bd, then show that h and k can be chosen so that substitution Substitution x is equal to z minus h, y is equal to w minus k reduces the equation dy by dx equal to f of ax plus by plus c divided by d of dx plus ey plus f to a homogeneous equation. So first consider that question. We are provided with AE not equal to BD. So answer we have given x is equal to z minus h and y equal to w minus k. So ax plus by plus c by dx plus ey plus f reduces to this form. Give the substitute for x, give z minus h and y give w minus k. You will get such an expression. And what is dx? It is dz, dy dw, and dy by dx is dw by dz, and dy by, and thus this equation becomes this equation dy by dx equal to f of ax plus by plus c divided by dx plus ey plus f becomes dw by dz is equal to f of this much quantities, which is homogeneous as in the last case, which is homogeneous if the constant terms, these are all constants, and these are all constants, they are equal to 0. That means ah plus bk minus c equal to 0, dh plus ek minus f equal to 0. If such an h and k exists, we can say that it will be a homogeneous, it can be reduced to a homogeneous equation. So using Cramer's rule, see, applied, h divided by these two, product of these two, y divided by means plus plus these, sorry, h divided by b into minus f minus c into minus c into e, that is minus bf plus c equal to k divided by minus cd plus minus cd plus e plus fa or af minus here is minus, minus of minus becomes plus. Similarly 1 divided by AE minus BD. So that H is minus BF plus CE divided by AE minus BD, and K is minus CD plus AF divided by AE minus BD. H and K exists if and only if AE minus BD not equal to 0. And it is given in the question that condition is provided, A minus BD not equal to 0 since this the given quantity. Thus H and K exist. So by the substitution, x is equal to z minus h, y is equal to w minus k, we can reduce the given expression, this one, to homogeneous equation. And the second part is, if A equal to BD, then show that there is a substitution that reduces the equation in A, this equation, to one in which the variables are separable. So if this quantity is equal, then this expression becomes variable separable. Shall consider that question. If A equal to BD implies A by D equal to B by E equal to a quantity, say L. So that D is A by L and E is B by L, and find a substitution Z equal to AX plus BY, which gives dx plus ey, that is the denominator of this expression, dx plus ey equal to a by L x plus b by L y equal to 1 by L of z. Now equation number 1. 1 implies 1 by b into dz by dx minus a equal to f of z plus c by z by L plus f by this method, and this is obtained from these quantities. Z equal to ax plus by dz by dx is a plus b dy by dx, and b dy by dx is dz by dx minus a, so dy by dx is 1 by b into dz by dx minus a, which implies dz by dx minus a is equal to b into a function of f of z plus c by z by L plus c. So what z means ax plus by, and z by L is dx plus ey from our equation number 1. So what is dz by dx? It is b, this quantity b into f of z plus c by z by L plus c minus a. Consider this function c z plus c by z by L. L is a constant plus c, that means f is completely a function of z alone. C is a constant. Sorry, C, here's C. In the place of C, you put F. Here it is F. So please correct it. Z by L plus F. Here also F. So both are constants. So please correct it. C Z plus C by Z by L plus F. Here also Z plus C by Z by L plus F. So this is a function of z alone, and so we can write this as phi of z. So here it is dz by dx, and this quantity is equal to phi of zc. So this is variables separable. These two, consider these two, it is variables separable. Thus if a equal to bd, by this substitution we can make the given equation 1 a variable separable equation, differential equation. So thank you.